For the first questions, obtain the area A in meter square of the circle and hence find dA over dr. So as we know, the formula of the circle is A equals to pi r square. And then based on this equation, we can differentiate to dA over dr, and the answer will be 2 pi r meter square. For the second questions, calculate the rate of change of the area dA over dt when the radius is 40 meter. First, dA over dr is equals to 2 pi r. Meanwhile, dr over dt is equals to 2. We get dr over dt equals to 2 from the statement, which is the radius of the spill oil is increasing at a constant rate of 2 meter per second. From dA over dr and dr over dt, we can get the dA over dt. To get dA over dt, we need to times dA over dr and dr over dt. When we times dA over dr and dr over dt, we can cancel out the dr. So after we cancel out the dr, we get dA over dt, and we can times 2 pi r and times by 2. So the answer after we times 2 pi r and 2, we get 4 pi r. After we get the 4 pi r, we can substitute the r with the 40 meter. So for the last calculation, dA over dt, we can substitute 4 pi r, which is r equals to 40, and after we calculate, we get the 160 pi meter square per second.
Okay, so first of all, by using the formula for calculating the volume of cone, which is 1 over 3 pi r square h, we are going to replace the r to find the dh over dt. So we need to do ratio first. H equal to 16 cm and r equal to 4 cm. So we are going to use the ratio formula, which will lead us to r per h equal to 4 over 16. Then we will transfer the h to the back, which will equal to r equal to 4h over 16, and then we are going to get r equal to h over 4. After that, we are going to replace the r in the cone formula with h over 4. So it will be 1 over 3 pi h over 4 square h. And we are going to expand the h over 4, which will go to 1 over 3 pi h square over 16 h. Then we are going to expand some more, which will lead us to 1 over 48 pi h cube.
Okay, next, we use implicit differentiation method to 1 over 48 pi h cube, and we can get dv over dt equal to 3 times 1 over 48 pi h square dh per dt. And after that, we will expand it, and we can get dV over dt equal to 1 over 16 pi h square dh per dt.
So lastly, we are going to make the dH over dt as the subject. So we need to transfer the dH over dt to the front and dV over dt to the back, which relates us to dH over dt equal to dV over dt over 1 over 16 pi h squared. And then, as stated in the question, the dV over dt is 2 cm cube per minute. So we are going to replace the dV over dt with 2. So dH over dt equal to 2 per 1 over 16 pi, and h as stated in the question is 8 cm. So we will replace the h with 8. So 1 over 16 pi 8 square. And then we are going to expand it. So dH over dt equal to 2 over 64 over 16 pi. Okay. Then dH over dt equal to 2 over 4 pi. And then lastly, dH over dt equal to 1 over 2 pi, which will lead us to the final answer, which is 1 over 2 pi cm per minute.
For question 3, we need to find the maximum value using first derivative test. There is given 0 for the lowest value of t and 6 is the highest value. The first step of first derivative test is to find the critical point. To find the critical point, we will start by differentiating the given equation. After differentiate, we need to let Vt equals to 0 in order to factorize the quadratic value and get the critical point.
The next step is to find action point, which we can see the maximum value of t is 6. To find the absolute maximum value of the drop in voltage is by replacing t with 6 in the given equation. Then the absolute maximum value of the voltage is 36.